Hello, so I'm going to be working problem number 21 from the test review, just to kind of go over bearing again. It's been a while since we looked at it and we only looked at it briefly. It's also good to look at a word problem using triangles because we did not get to do any of these in class. So I'm going to show you a bunch of techniques for using everything that we learned in class with the triangles in the word problems. The main thing is learning how bearing gets applied to actual triangles. Okay, so in problem number 21, we've got an airplane, and most of these problems are going to be airplanes, boats, something that's moving. So we need to have our compass drawn as our coordinate grid for this kind of a problem. So we've got an airplane going from airport A to airport B. Now, the next thing is, as I'm going to start setting up the drawing as I read, the starting position for whatever's traveling, boats, planes, whatever it is, the starting position is always going to be at the origin. So wherever they're starting and going off in a certain angle, that's at the origin. So in this case, the plane is starting at airport A. That becomes my origin of my compass for now. And then he's traveling towards airport B, and the problem tells me that airport B is 300 miles away at a bearing of N50E. Now that's pronounced 50 degrees east of north. And I think the pronunciation of it, even though it's a little bit backwards from the way it's written, it is much more descriptive of what we're actually measuring. We're starting at north and going 50 degrees east of that. So the angle for bearing is going to be in between north and that direction that we're heading. So I'm going to go ahead and draw that in. There's the direction that he should be heading to airport B, and the 50 degrees is how far to the east we moved to get in that direction from north. So starting here, moving, and whatever span you cover in that moving of 50 degrees is where the angle falls. So it's not going to be ever against the x-axis, which is where bearing is a little bit different from what we've been doing. You can calculate the angle next to the x-axis, though, if you need it. So since this is a 90-degree angle, the angle right in here is going to be 40 degrees, and we will use that in just a second. It's saying that airport B is 300 miles away, so the length of that side is 300 miles. So far, this is what I got just for the first sentence. Then it says that the pilot drove or flew exactly east 200 miles per hour for half an hour. So he went a total distance of 100 miles before realizing that he made a mistake. Now, the first question is asking how far is he from his destination at the moment when he discovers that error. So what I need to know is that distance away from where he is to airport B. So this distance right here. Now you can see now that I've drawn in those two directions and that third distance that we're trying to find, we've built a triangle. And we won't assume that it's a right triangle unless they told us that he was directly beneath airport B. But we don't know that, so it could turn out to be a right triangle. We're going to have to figure that out. Now, as I go to solve for side X, if you don't have the different cases of triangles memorized, you may want to start by building Law of Sines, and then you'll notice that we actually don't have any complete ratios, pairs of angles, and the sides associated with them. So I can recognize here, just from my drawing, that I am going to have to use Law of Cosines to solve for that X. So let's go ahead and build our equation for Law of Cosines. Now, as usual, the only angle that I have is the one that's going to have to go into the formula. So I'm going to use angle 40 degrees as the cosine part. And then the side associated with that, which would be the x, goes on the left side of our formula. And then for everything in between, we're going to use the other two sides of the triangle, meaning the 300 and 100 that we do know. So I'm going to square each of those, add them together, and then subtract away 2 times those two sides. And that's our entire formula. Now, before I start plugging things in, I always double check, make sure that there's only one unknown in that entire equation. And in this case, there is. So now I'm going to go ahead and type that all into my calculator. And so I'm going to type it all in, and that's going to give me the x squared, but then we have to take the square root to find x. So let's go ahead and type that all in. 40, there we go. Okay, so that's going to be x squared, and then we just square root that number to get x, 232.5 after I round. And so I'm going to go ahead and draw that into my triangle. And that would be the units, the answer to part A. That one was the simple one. Now, part B is the one that can get a little confusing because you have to understand, once again, the main part of bearing is that starting position, wherever you're starting from and then going somewhere else, that starting position is what should be at the origin. So in this case, he was supposed to be starting at airport A and going to B. But we've noticed that he's over here now. And so the following question is, what bearing should he head in to arrive to airport B from that position that he's at right now? So I've drawn a second coordinate grid because this is now where he's starting as he's deciding what bearing to go in. So that point should be now at my origin when I make this decision. So I'm going to redraw my triangle with his new starting position at the origin. Okay, I think that's everything. And the bearing, once again, should be from where he's at, what angle he needs to go in to get to his destination. And it's always the angle compared to north or south. So I'm needing, for part B's answer, this angle right in here that I'm going to call theta, just because that's a nice variable for that. Okay, so I need to find theta. Now, I don't know very much about this small triangle, although that would be very helpful because that's the angle inside that triangle formed with the north-south axis. I don't know anything about it other than this one side, though, so I can't really use it. What I can use is this big blue triangle that we've been working with, and I can find that angle right there because I have all the sides, so I have enough information to find that angle. And then I also noticed that because these two axes are perpendicular, this over here is a 90-degree angle. So if I can find the entire blue angle and take away the 90 degrees, I'll be left with theta. So that's where I'm going to go for this next step. We need to find that big angle. You can do this a couple of ways. I'm going to show you that one method will work and one method doesn't necessarily work. Remember the rule about solving for the largest angle first? Well, if we try to use law of sines with an obtuse angle, it's not usually going to give us the correct measurement. So let's try it and we'll see what goes wrong, and that will kind of help guide you in the future towards why that's not going to work. What I want to do ultimately is use law of cosines, because cosines doesn't care whether it's obtuse or acute. It will always give you the correct angle measurement. So let's try law of sines in this case. Sine of 40 degrees over 232.5, because that's our one complete ratio. And then I need to use this angle with the side across from it for the second one. We'll just call that angle C since these are A and B. All right, so in my calculator, I'm going to type all of this in and then take the sine inverse of that. All right, so that's what I was hoping to see. So you'll notice that that is definitely not the large angle that we're looking for in this triangle. That is way too small because our angle that we're looking for is definitely bigger than 90 degrees, and that's definitely smaller. So this is what happens when you do not solve for the largest angle first. And basically what that implies is, since your first step should be law of cosines and your second step is usually law of sines, if you don't get the biggest angle in the law of cosines step, then law of sines is going to fail you. And the reason for this is the law of, or the sine of this particular angle that it did give us is the same as the sine of the angle we're actually looking for. But remember, sine inverse is only going to give you answers in these two quadrants. The angle we're looking for is over here in quadrant 2. So we would have to calculate that by doing some of those, some of the processes that we did a couple of units ago, trying to find that second angle. The alternate option besides doing that extra work, is to just use the law of cosines if you know that your angle is going to be obtuse. Because cosine inverse goes from 0 to 180, which is any angle inside of our triangle. So cosine inverse is going to give you your angle no matter what. So let's go ahead and retry this with law of cosines. We have angle C, and the side associated with it goes on the left side. And then the two other sides and I think I'm going to run out of space. Hopefully you can see what I'm trying to do there. Other two sides squared minus 2 times the other two sides times cosine of C. And now I need to get that cosine of C by itself, so I'm going to move these terms over to the other side. And now this, oops, I left off an equal sign. There we go. This is all a coefficient in front of the cosine, so we need to divide it now. Okay, and then I'm going to take the cosine inverse of both sides. Now I'm just going to do that in the calculator. One thing I wanted to warn about was every time you're doing this with the multiple terms and you're trying to plug it all into your calculator at once, you do have to use parentheses for both the numerator and the denominator. Otherwise, your calculator is going to do things out of order or out of the order you would expect. So I would like to do it in 3 steps instead, just to avoid that issue altogether. I'm going to do the numerator first. Then divide that by the denominator. And then I take the cosine inverse of that number. Okay, so this is giving us our obtuse angle, telling us that C is 123.9 degrees. Now I want to show you something. This is kind of off topic, but it shows you why we got that really small angle at the beginning. So the sine of that really small angle and the sine of this angle should actually be the same, and your calculator just always gives you the smaller of the two whenever you do the sine inverse. So for this one, we're going to do sine 123.9 and calculate that, and then sine of the other angle, which I've already forgotten. It was 56 degrees. Okay, so now calculating the sine of both of those, this part is not needed for the problem. I'm just showing you once again why you need to solve for the largest angle first. Sine of 56.04. Notice that they're almost the same. We rounded, so they're a little bit off, but they are the same number. So when your calculator is doing the sine inverse of this, it's going to give you the smaller one, not the bigger one. So that's why we have to use law of cosines to find that bigger angle. Otherwise, we have to calculate that one ourselves. So we finally found our angle, 123.9. And again, at this point, we've done 90% of the work. The last thing is just to subtract away the 90 degrees to get the theta. So theta is 123.9 minus 90 degrees. And so we should get 33.9 degrees for theta. And now we just need to write it as a bearing. Bearing is always north or south first, then your angle, and then whether you're on the east side or the west side of north. So that's your final answer. Now we did a lot of extra work, so I want to kind of summarize this one more time. We found this third side using law of cosines. Then we have to identify the bearing angle and use the triangle's angle to calculate it. So we found that big one using law of cosines, subtracted away 90, and found theta. With each of these, you have to get a little creative when you're trying to find a missing angle. The most important thing is if you understand how bearing is written and what it means for your triangle, then finding the angles is stuff that you've already practiced and you're pretty good at it. So good luck on the others. I'll post more videos if anybody needs them. I'll look through the other problems and see if there's any other issues that might come up that are not presented in this problem. But for now, I think this is a pretty good introduction to bearing.